Now we have to find the sum of an infinite series, and this is a hard question. So we need to find the sum of the infinite series, which is this one. Now r and k are proper functions, which means that the numerator of the value of r, the power of the numerator of the value of r, is less than the power in the denominator, and same goes for k, as it is a proper function. Now this is a bit tricky, isn't it? So let's just see what we can do with this. This is what is given to us, and if we multiply the left hand side and the right hand side by 1 minus k, this is what we get. Now you'll see in a second why we did this. When you expand this, you get this series, and you'll notice something about this series. You have terms with just r in them, and you also have terms with rk terms. So you'll convert this into two different series, one with the r terms and one with the rk terms. Now these are geometric series. Why? Because, oh, and also another thing, since the rk terms are actually negative, you just take the negative sign common and make the rk terms positive. So now these are geometric series. Why? Because look over here, this has a common ratio, because r squared divided by r is equal to r, and r cubed divided by r squared is also equal to r. So you have a common ratio, which is r. Over here you can see that r square k square over r k is equal to r k, and r cube k cube, which is the third term, divided by the second term, which is r square k square, is also equal to r k. So the common ratio is equal to r k. So now we have two geometric series, and so we can apply the formula of S infinity, and that was S infinity is equal to a1 over 1 minus r. When you apply that on these two geometric series, you get this. So you get this basically. The S infinity for this geometric series is this, because a1 is r, which is the first term, and the common ratio is r, so 1 minus r. And for the second geometric series, you have this, because the first term is rk, so a1 is rk, and r is also rk, which means that it becomes rk over 1 minus rk when you apply this formula. So when you take the LCM of these two, you get this, and when you expand this further, you get this. And so you remember that we multiplied 1 minus k on the left hand side, so what you'll do is, in the numerator on the right hand side, you'll take r common, and then that becomes r into 1 minus k. These two will be cancelled out, and so for S infinity you have this, and this is what we had to find in the question, an expression for S infinity, the sum of the infinite series.